In the last video, I talked all about promises inside of JavaScript, and I told you in this video, I'm going to show you how to use async await to write promises in a different and cleaner way. So I have just a simple set timeout promise here that we created in the last video. As you can see, it's just returning a new promise that resolves our set timeout. So if we call set timeout promise, and inside of here, we pass it a delay of 250, and then we do a dot then. Inside of here, let's just say we console.log1. We save. You can see after 250 milliseconds, it prints out 1 over here. And we can chain these together by saying return that timeout promise. This one is going to just be another 250 millisecond delay. We can have another dot then. Inside of here, we could say console.log2. There we go. We have 1 being printed and then 2 being printed after that 250 millisecond delay. We took a look at this in the last video, and this should make sense to you at this point. We're just chaining together these different promises. But the code is still kind of difficult to read. It really doesn't make intuitive sense exactly the ordering of how everything works. So JavaScript decided to create async await instead. Let's take a look at what async await is. In order to use async await, you actually need to be inside of a function, and you need to make sure you mark it as an async function. Let's create a function. We're just going to call this do stuff. In this function, to tell it that it's async, you just put the async keyword at the beginning. So you just type out the word async, all lowercase, then a space, and then the function keyword. It has to be in this order. You can't put function at the beginning. This doesn't actually work. You need to make sure async goes first, and then the keyword function, and then the name of your function, just like a normal function. You just put async at the beginning. Now this is telling JavaScript, hey, this is async, and we can use the await keyword in here. What I want to do is duplicate this code up here where I have a promise, and then after that promise is finished, I have another promise executed. So let's just say set timeout promise of 250. And what I want to do is log out, 1 after this is finished executing. So what I can do here is I can just say await. And what this is telling JavaScript is it's saying, hey, this is my await keyword. And afterwards, I have a promise. This is a promise that's being returned. Now what I want you to do is I want you to wait until this promise finishes executing and resolves, and then continue executing all of my code. So what happens is JavaScript sees this and it says, okay, I'm going to wait. And it just does other things. It goes and works in other parts of your code. It handles other click event listeners, and it doesn't come back here until this promise is done. So in our case, 250 milliseconds later, then it's going to come back here and we could say console.log1, just like this. So now if I save this and I just execute do stuff and I comment out this code right here, I save, you can see after 250 milliseconds, we get 1 being printed out. Okay, that's great. So we have this working as we would expect. What happens if we wanted to change this to another promise? Well, what we did is we waited 250 milliseconds and then executed this code. So now here I can just say await set timeout promise for another 250 milliseconds, and then console.log2. Now what happens is I get 1 and then 2 being printed out. And this code makes much more logical sense than the code up here because it's just like normal synchronous code. And the idea of async await is to make your code look like synchronous code while actually being asynchronous. So it's easier to read while also having all the benefits of having asynchronous code. So as you can see here, this reads top to bottom. It's saying wait 250 milliseconds, do this. Wait 250 milliseconds, do this. Just normal top to bottom code. This set timeout code up here, it technically reads top to bottom, but it's a little bit more confusing to understand as compared to this async await code down here. And if you accidentally forget this async keyword and save, you're going to get a really helpful error that just says uncaught syntax error. Await is only valid in async function. Just to remind you that you need to have async at the beginning of your function like this. Now let's say that we were to modify this set timeout promise a little bit, and instead of just calling resolve, we actually passed something to resolve. So let's say that we passed a string in here that just says you waited, and then we pass in the delay milliseconds. Just like that. So essentially it's saying you waited 250 milliseconds in our case. So what's going to happen? How do we get this resolve inside of here? Because we know that if we did it with our set timeout promise version up here, we could just say message and console.log message. We can do the same thing down here, message and console.log message. And now if we comment this code out down here, you can see it says you waited 250 milliseconds 1, you waited 250 milliseconds 2. We're able to access the return of our resolve here. Well, to do that with async await, essentially all you do is you pretend that this is just a normal function. When you use async await, you say, I'm just going to pretend this function executes immediately and that there is no delay, and the return of it is just our resolve. So I can say const message is equal to whatever the return of this promise is. And then I can console.log out that message. Do the same thing down here. Const message2 is equal to this. And I can console.log message2. Now, if I save this, you can see I get the exact same result as with what I had up here. So when you use async await, whatever resolve has inside of it is just the return value of our async await execution of that promise. But how do we handle errors? What happens if instead of resolving, we're rejecting? And we're just going to reject and it'll say error. So now what actually happens, you see we get an uncaught in promise that says error. The reason for that is we don't have any catch inside of this system. If we comment this out and move up to our promise version here, all we need to do is just, put a simple .catch inside of here. We can say that it's going to take an error. And we can, inside of this .catch, just say console.error of our error. And we can put this catch all the way at the bottom. That way it'll catch either one of our promises failing. Now if we save, you can see it catches that and prints out the text error for us, as you would expect. So how do we do that inside async await? Well, it's actually pretty straightforward. What we need to do is wrap our code inside of something called a try-catch block. So to do that, you type out the keyword try, followed by curly braces. And then at the end of this, you type out the keyword catch, followed by again curly braces. And this catch takes in here an argument, which is our error. And this must go inside of parentheses just like this. You can call this anything you want, error, whatever you want. It just is the error that happened that caused your code to fail. What you do is you put all the code you want to check inside of try. And what this does is it says, I'm going to try to execute this code. And what it does is it executes the code, and as soon as it runs into an error, it exits out and runs the code inside a catch. But if it executes all the code inside a try successfully, this catch is completely ignored. So inside of here, let's just do console error, error. Now if I save, you can see that our error is properly being caught down here, as we would expect. I can even just say console.log here. As you can see, it's logging out here. And if I come up here and say console.log before error, and I put a log here that says after error, you're going to notice it says before error, then it waits 250 milliseconds, it fails, it says here, because it exits this immediately, it skips all the code down here, goes straight into the catch, says here, and then console.logs out our error. So if you ever want to deal with catching an error inside of an async await, you need to wrap all of your async code inside of a try, then put a catch at the end to make sure you catch any errors that occur inside of it. And this is not going to just catch errors inside of your actual promise, but any error. So if we just type in some bogus code like this, you can see we get that error being printed out immediately. So just like with promises, this is going to catch any error, not just the errors with your actual promises themselves. So now it's your turn to play around with this. What I want you to do is I want to use these two functions. We're going to call this getValue with delay. This is going to take in a value and a delay, and I just want it to resolve with the value. So essentially you pass in a value and a delay, and it's going to wait whatever your delay is and then return to you that exact value. So here we go, we have getValue with delay, and then we're going to have getValue with delay error. And this is just going to, instead of resolving, it's going to reject with the text error. There we go. So we have these two functions, and what I want you to do is I want you to write an async function that essentially is going to call, here we go, I'll write the code for it here. We're going to say call getValue with delay twice and print out the returned value. Then call getValue with delay error and make sure that the error is properly caught. What I want you to use is the async await keywords in order to try to do this with async await, and then make sure you use try catch properly to catch the error returned by getValue with delay error. So pause the video here, give yourself a chance to try this out, and then I'll show you how it's done. So hopefully you've taken a little bit of time to try this out. We have our two different functions here. What I want to do is just create a new function, which is async, as we remember. We're going to call this do stuff again. It really doesn't matter what it's called. And we'll make sure that we call this function down here. Now inside of here, I want to just first wrap everything inside of a try with a catch that catches our error. and we'll just do console.error of our error. So immediately we're just going to log out our error if we have one. Then what I want to do is get value with delay. So we can say const value1 is equal to get value with delay. We're going to pass in here a value of, let's just say Kyle, and a delay of 250. And then we're going to log that out. So console.log value1. And again, since this is a promise, we need to make sure that we await this. So we have the await keyword here. And if we save, we get Kyle being printed out after a delay. If we forget the await keyword, you're going to notice we get this weird promise object being returned, which has information on the state as well as the result. So if you see that, that means you most likely forgot to actually await your promise to make sure it finished executing. Let's just copy all of this because we need to do this twice. This is going to be with a second value. We're just going to pass in cook here, for example, and print out value 2. Now we get Kyle, and then after a 250 millisecond delay, we get cook. And then we can have our error state. So we can say const value3 is equal to await get value with delay error. Let's just pass in here a value of high and another delay of 250. And then we'll console.log value3. This isn't really important since we know this is going to fail, but if you had normal code, you would have this because you would want to print this out. Now if we save, we get Kyle, then we get cook, and then finally we get our error because this one actually errored out, so it no longer logs our value 3 and instead skips down here and logs out our error. And that's pretty much everything there is to async await. The last thing I want to talk about though is the finally keyword, because if you remember in promises, we could say .finally, and that would execute no matter what if we failed or succeeded our promise. With a try catch, we can add a finally onto the end of our try catch, and this will execute no matter what happens in our try catch, whether it all succeeds or all fails. So we can just say console.log finally, and what happens is we get Kyle, then we get cook, then we get our error, and then finally being printed out. And if this here was not an error and actually was successful, you'll see it gets Kyle, then cook, then high, and then again finally gets printed out because this executes no matter what. So we still have access to finally, even though we're using async await. And you can essentially replace any promise at all with async await, and it'll work just fine. The only thing to worry about with promises is that since they wait for the code to finish, as you can see here, we're waiting 250 milliseconds, then we're waiting 250 milliseconds, and then we're waiting 250 milliseconds again, which is 750 milliseconds of waiting. What happens if we wanted to run all three of these waits at the exact same time? That would be essentially the same thing as if we did this with promises by saying get value with delay, passed in, for example, Kyle, a delay of 250, then we did a dot then with our message, and we're just going to console.log our message. This is how we would do our delays in parallel by just taking this, copy it down multiple times. So we could do cook, and we could do high. If I comment all this out up here, and I run this, you'll see it'll wait 250 milliseconds, and then all of these will run at the same time. And that's because we queued them all up at the same time. We ran this, and then this. They don't depend on one another like up here where we were chaining our .thens together with our old promise way of doing things. And with async await, there's no good way to queue up a bunch of things at the same time. So if you ever are inside of a loop and you're waiting inside that loop, for example, if we were to do like for let I equal 0, I is less than 10, I plus plus, and inside of here we did get value with delay, we passed in I. If we were to do this inside of await, like this, where we had a function called do stuff. There we go. That way we can have an async function. And what we wanted to do is just console.log const value equals, and then we'll log out that value like this. So if we did this with async await, it's going to be really slow because it's going to take 250 milliseconds for each iteration, as you see here. And of course, nothing's printing. I just need to call the do stuff function. There we go. So what you'll see is each one of these numbers is going to print out after about a 250 millisecond delay. It's pretty slow, and each one is going to print one by one. But generally, this is not really something that you want to happen. You generally want to just execute these all at the exact same time. This is where promises would come in handy. Instead of using this async await keyword, what we could just do is .then, and then we could say inside of here that we wanted to put this console.log value, and this is going to take a value. So now instead of using async await, we don't even need this function anymore if we don't want. So let's just remove this. Now we just have a for loop that's doing a bunch of promises. And what's going to happen is after 250 milliseconds, all of these are going to execute because they all get queued up in parallel at the exact same time. So this is just one thing to watch out for with async await. If you're ever doing any form of looping or doing things one after the other where you're waiting, then waiting, then waiting, just know that you have to wait for the previous value before you can execute the next line of code. But with promises, if you're not chaining them, they execute in parallel, which means that they can all execute at the exact same time. So depending on your use case, if you need the previous value or not, it may make more sense to use promises instead of using the async await keyword. And that's everything there is about async await. In the next section, we're going to talk all about the advanced DOM features, and a lot of these features deal with asynchronous code and promises, so it's great for us to be able to practice the skills we've learned in this section of the course. I can't wait to see you in that next section.